Now that we have looked at how to calculate z-scores, we can move on to finding probability using the normal distribution. So when we're finding area under a standard normal curve for any application, we are going to follow these 4 steps. The first step is to calculate the z-score. Then we're going to draw the normal curve and label the z-score on that curve. We're going to shade the appropriate region under the curve. So we're going to look at the problem and we're going to look at whether the problem wants us to find the probability less than, greater than, or in between. And we are going to find the appropriate probability based on the verbiage. Then we are going to use Excel to calculate the area. I'm going to use Excel. There are other technologies, applications out there that you can use to calculate the area. But in these videos, I will be showing how to use Excel to calculate those areas or those probabilities, since area is interpreted as probability with a normal curve. So we're going to be using this same example for all of the examples that I have. And this example says, the lifetime of a specific brand of batteries are normally distributed with a mean lifespan of 500 days and a standard deviation of 61 days. So we have 3 really important things that I want to highlight before I go any further. The first thing is that the battery's lifetime is normally distributed. That is great. If I don't know that it's normally distributed, I cannot do what I'm about to do. Then we know that the mean lifespan is 500 days and that the standard deviation is 61 days. So over here off to the side, I'm going to go ahead and write mu equals 500 and sigma equals 61. And I'll rewrite that as I do each problem just so that I'm keeping it close by. So I'm going to follow my steps. So the first step is to calculate the z-score. So our z-score equation, z equals x minus mu divided by sigma. And I realized I got ahead of myself. I got excited. I'm so sorry. Let me read the actual problem. I just get so excited. Okay, so the actual problem we have to find now, find the probability that an individual battery lasts less than 650 days. So now in this problem, the things that we need that are important. The first important thing is find the probability. Obviously, that's what we're doing because that's the only thing that's what this is. You don't know how to do anything else, but you will eventually know how to do other things. So that is important. That's what we're being asked to do. An individual battery, one battery out of the population. Again, right now, we don't know how to do the probability for anything other than an individual, but eventually we will. And so this is important to identify. We're looking at one battery. Less than, we need that for step 3, 650 days. 650 is our x. That is our data value. So now I can jump down into my steps and do the first step, which is to calculate my z-score. So my z-score formula is x minus mu over sigma. My x value is the 650 days that we are interested in, minus 500 is the mean, divided by 61 is the standard deviation. So 650 minus 500 is 150 divided by 61. I'm going to go to 3 decimals on all of these. As I've said before, z-scores you typically want around anywhere from 2 to 4. 2 decimals was the standard for a really long time before we had technology. And it feels to me like we should just do more to be more accurate. Anything more than 4 feels just a little excessive, in my opinion, because we only round to 4 decimals for the probability. So 3 feels like a good compromise. I believe the standard is still 2, however. But I just feel like we could be a little more accurate than that. All right, so here's our curve. I already put one in here, so you don't have to watch me redraw it over and over and over again. The middle is always labeled as 0. And then we need to come and label 2.459. So this is 0, this is 1, this is 2, 3, and 4. So 2.459 is almost 2.5. It doesn't have to be perfect. The main idea of labeling this is recognizing that we're on the right-hand side of the mean and that we're going to be pretty far away. We're not way out here, but we're also not in here. Okay, we're a good distance away, but we're not way out in the beyond of the graph. So that was step 2, drawing the curve and labeling it. Draw and label Z. So now step 3 is to shade the curve. And our shading is based off of the words less than. So we want to shade everything to the left of our z-score. So I'm going to start at my z-score and I'm going to shade everything to the left. And this is a point where if you want to do some nice color therapy, you want to make it look really good, this is a great chance to do that. You also can just do a quick shade like this. This is so that you can visualize the probability that we're going to be calculating. So when I see this, I can see that I've shaded almost the entire curve. And if the entire area under my curve should equal 1, and I've shaded almost all of it, there's this little region over here that is not shaded. That means my answer, my probability, should be pretty close to 1, but it shouldn't equal 1 because there is this little area over here, that spot there, that I didn't color in. And this helps me visualize the probability that I'm trying to calculate. And now I'm going to go into step 4, which is to use Excel. So when I use Excel to find the area, I am going to go into Excel in a second, but I'm going to write down what I'm going to do in Excel first. In Excel, this is what I'm going to type. I'm going to type equals to tell Excel, hey, I need you to go and calculate something for me. Thank you so much. And then I'm going to type norm.s.dist. So I'm telling Excel, hey, I'm using the normal distribution and I've got z-scores. Please calculate the area of the following. And I'm going to put in 2 things. I'm going to put in my z-score, 2.459, comma, true. And what the true does is it tells Excel, I want you to take the z-score, 2.459, and I want you to find everything to the left of it. If I put 2.459 comma false, it would find just the probability of being equal to 2.459. And that's not what we want. We don't want just 2.459. We want everything less than 2.459. So norm.s.dist, the z-score, comma, true. And we do true so that it does everything less than the z-score, not just equal to the z-score. So I'm going to switch to Excel for a second so that we can type this in. And I'm going to forget, okay. I was going to forget the z-score if I didn't have it in my calculator. So here's my Excel screen. And I have to turn on my keyboard. All right, so I do equals norm.s.dist, and then 2.459 was our z-score, comma, true. And that's all we have to type in to get this probability. And it's going to give us the probability of everything that we shaded. I hit enter, and I get 0.993034. And we can round that to 4 decimals. So 0.9930. So I'm going to go back to the notes. And that looks pretty good. That's close to 1. It's not equal to 1, so it does show that we have a little bit of area unaccounted for, but it's really high. So this is how you find the probability using the normal distribution of something less than.